Hi there. In this short video, we're going to briefly look at some of the capabilities across the Labelbox platform that are available to support in generating training question-answer pairs for the purpose of fine-tuning an LLM. In particular, we're going to look at how we can train an LLM to generate SQL responses to conversational questions or prompts. We join here where we've rendered our dataset within Labelbox. This can be achieved through various means, from simple drag and drop approach from within the UI, to one-off uploads via Labelbox's API using Python, or by establishing synchronized and automated ingestion pipelines to your cloud storage. In this case, our dataset consists of natural language prompts, which we have attached schemas. These schemas show the structure of the relevant database that should be referenced when generating our SQL responses. We can see here that we have the names of the individual tables, as well as the titles of our columns and the data type that each column is. We'll use this when we come to generating our responses and can act as a guide. The first thing that we're going to want to look at is how Labelbox's catalog product can be leveraged in order to curate and understand our data. The first thing to note is that scrolling to the top of the UI within Catalog, we can see the various filters available to us in which to filter our data. We see we can filter by batches, we can filter by natural language, metadata, annotations. These filters can be applied both for an individual dataset or across our whole repository. Additionally, we can also filter by dataset of interest. However, we first need to understand what it is that our data consists of. We can see from visual observation that we have various different topics being discussed, from healthcare to geography to airlines and aviation. However, if your data set is too large to understand in a visual inspection in this manner, we can also enable cluster view. Cluster view projects your data rows in two-dimensional space for you to be able to zoom in and understand specific clusters. For example, looking at this cluster here, we can see that each of these data rows relates to aviation. Again, we can look at this cluster here. And here we see this relates to education. We can use this approach to observe each cluster and understand the topics being discussed within each. Once we have an idea, we can navigate back to our gallery view and use our understanding in order to create subsets. For example, if I search through natural language, I can type in a semantic such as aviation, and I can adjust the overall similarity threshold to arrive at a useful subset of my data. As we can see here, each of these data rows seems to relate to airlines and therefore is referencing a specific database. We can now go ahead and save this as a slice. The advantage of a slice is we can think of this as a subfolder within our repository. In the case that we're uploading more data in the future, as and when data rows are uploaded that meet the criteria specified at the top of a slice, these will automatically be filed accordingly, allowing us to curate over time our overall repository. Now that we've identified a useful subset of our data, we can go ahead and begin to label this. The first thing that we need to do when looking to label any data is to define what we at Labelbox call an ontology. This is what specifies the attributes of our data rows that we're interested in annotating. We can navigate to the Schema tab, making sure to have ontologies selected at the top, and we can go ahead and create a new ontology. Here we see all the media types that Labelbox supports. In our case, we're interested in generating LLM training data, so we can select the LLM data generation option at the bottom. We now have three options here. We're going to go ahead and select the third option, that is, to generate a response to already uploaded prompts. We can then name this something appropriate, such as SQL demo, and we can go ahead and add responses The first response is obviously going to be the SQL code that we're interested in. And in this case, we're going to change it to a free text option. We can specify the minimum or maximum number of characters for our free text response. However, in our case, we'll leave these. Additionally, we may be interested in tagging the topic to which our prompt is related. This allows us to not only generate our SQL response, which we can use for training, but also to enrich our data as we go through. We can add various options here, such as aviation, education, retail, industrial, so on and so forth. Again, we have the option here of radio checklist or text. We'll go ahead and select radio, which indicates just one option from the drop-down provided. Now that we have configured our ontology, we can go ahead and create. The next stage is to set up an Annotate project. We can navigate to the Annotate tab, go ahead, select New Project, and again we're going to select LLM data generation. Making sure to select the correct option as before, we can go ahead and click Next. Here we can name this something appropriate, such as SQL LLM, and we can go ahead and click Save. Next stage is to add our data. So let's navigate back to the slice that we had identified before, select all, and use the Send to Annotate option. Here we need to make sure to select the project that we've just created. We can define the batch priority. However, in this case, we'll keep it as 5, which is the lowest priority, and we can name this anything identifiable and relevant. We'll keep it with the default batch 1 naming convention, and we can click Submit. Now, navigating back to our project, we can see that the data rows have been passed to it. The last thing we need to do is to add our ontology before we can begin labeling. Now that we've added our ontology, our project is configured and ready for us to begin labeling. Labeling can be done by individuals within your organization. However, in the event that you don't have capacity or are looking for subject matter experts, you can utilize Labelbox's Boost Workforce offering. This program offers customers the ability to source labelers through Labelbox with specialized knowledge and skill sets required to annotate the features of relevance across your dataset. For the purpose of this demo, I will go ahead and show you how we can begin labeling. To do so, you can navigate to the Start option in the top right and select Labeling. This will bring up the labeling UI. Along the top, we see the natural language prompt or question being asked. We have our free text box here where we can generate our SQL code, and we have the topic shown at the bottom. Additionally, we're presenting to the labelers the schema to help guide their response. In addition, we have various capabilities that can help support code generation. For example, we can insert a code block. In addition to that, we can also display the formatted code to the right. Now, as we go ahead, we can generate our response using SQL syntax, for example here, and we can see this visualized on the right-hand side as would be if executing within code. Additionally, we can go ahead and select the topic of interest, and we can click Submit. We can continue to generate responses in this manner. Next, we can see the review process. Navigating back to our overview, we can select Workflow. Visualized here is the default workflow that is set up for your projects as standard. This can be configured with additional workflow tasks and reviews. However, let's talk through each of these stages. Initial labeling dictates that these are data rows that are yet to be viewed by our labeling workforce. Labelers will annotate these, at which point they'll fall into a review task. A reviewer can reject, for whatever reason, a data row. They can also add comments to dictate why this was, at which point it will be moved back to rework, where a labeler can revisit and refine. If, for example, we wish to start reviewing, we can add comments as necessary and save these if we intend to reject. However, in this case, we can go ahead and approve. Doing so will move that data row into done. Once all data rows sit within done, they can be extracted for downstream exercises such as fine-tuning of our model. We have now looked at how we can manually generate LLM data. We see here, for example, this is the outputted data row showing the initial prompt as well as our SQL code and topic. However, let's look at how we can leverage cutting-edge AI models in order to generate pre-labels which can then either be used as per or reviewed by a human in the loop. To do so, let's select sample data rows and we can click the Predict with Foundry option. Foundry within Labelbox enables API connectivity to some of the cutting-edge, state-of-the-art foundation models. In addition to those hosted by Labelbox, you can also deploy any custom models from within your organization through various means. If of interest, please reach out to Labelbox to inquire. However, for the purpose of this demo, we'll go ahead and we can leverage GPT-4, for example. We can select an ontology. In this case, we're just simply asking for a SQL response, and then we can provide additional information in our prompt. Here's one that I created earlier. Helpful assistant, based on the schema, accounting for the database schema structure, please respond with a SQL code that would provide the answer to the question being asked. Additionally, we can provide one or more examples. Here, the input is the question being asked, and the response is the one that we created previously. We can go ahead and select Generate Previews, or alternatively, submit a full run. The advantage of generating previews is it will enable us to see whether or not we're seeing adequate model performance before executing across our wider dataset. For the purpose of this demo, we can select Generate Previews. We can wait a few moments for a response to be generated before exploring. Here we see the question being asked, and we see the SQL response. Select count model from our table, grouping by that particular column. And again, we see a more complex response using SQL syntax here. These can be stored, taken externally for training, or indeed passed through to a human in the loop in Annotate, as we've seen previously. Hopefully this gives you an idea for some of the capabilities that are available across the Labelbox platform to help in accelerating the generation of LLM training data.